It is known that on average, 1 in 300 flowers of a certain kind are white. A random sample of 200 flowers of this kind is selected. We see that n is equals to 200, and the probability of obtaining a white flower is 1 out of 300. Part A, use an appropriate approximating distribution to find the probability that more than one flower is white. So for the sample size, n is equal to 200, and probability of success is 1 out of 300. This is actually a binomial distribution, and we can approximate this to a Poisson distribution. Since n equals 200, this is large, and the probability of success is small. We can let x to be the number of white flowers. In a sample of 200. And for part A, because n is large and p is small, we can approximate the binomial distribution by a Poisson distribution. And the lambda for Poisson distribution is given by np, which is 2 out of 3. Then we say that x follows a Poisson distribution with lambda 2 over 3. We need to find the probability that more than one flower is white. We find the probability that x is greater than 1. And this is the same as the probability that x, 1 minus x, less than or equals to 1. We use the complement rule. Probability x less than or equals to 1 is equivalent to probability x equals 0, and the probability that x is 1. And we solve this using Poisson. So we have 1 minus e to the negative 2 over 3, 2 over 3 to the 0 over 0 factorial, minus e to the negative 2 over 3, 2 over 3 to the 1 over 1 factorial. And this has a value of 0.144. Part B, justify the approximating distribution used in part A. To justify the approximating distribution, it is insufficient to say that n is large and p is small. Large, how large is large? So for Poisson approximation to the binomial, n is 200, which is greater than 50. We consider 50 to be large for Poisson approximation to the binomial. And also np, which is 2/3 here, this is less than 5. So this will tell us how small of a p is considered small. When these two conditions are satisfied, we can use a Poisson approximation to the binomial. The probability that a randomly chosen flower of another kind is white is 0.02. We have another kind of flower here. The probability of it being white is 0.02. A random sample of 150. We draw a random sample of 150, n is 150. And we need to use an appropriate approximating distribution to find the probability that the total number of white flowers in the two samples is less than 4. For the second kind of white flower, we see that n is 150, this is greater than 50, and p is 0.02, we can compute np, which is 150, times 0.02, and that has a value of 3. This is less than 5. So n is sufficiently large and p is sufficiently small to approximate this distribution by a Poisson distribution. We can let y to be the number of white flowers in this distribution. So if y is the number of white flowers in this distribution, we say that y follows a Poisson distribution with parameter 3. Okay, this is for the second kind of white flower. For the first kind of white flower, we have x. Since x and y are independent, we see that x and y are independent. Then we can use v to be the sum of x and y. And v follows a Poisson distribution. The parameter would be 2/3 plus 3 here. So we say that v follows a Poisson distribution with parameter 11/3. Lambda is 11/3. This v will give us the total number of white flowers in the two samples. And we need to find the probability that v is less than 4. We have probability x, we have probability v equals 0 plus probability v equals 1 plus probability v equals 2 plus probability v equals 3. This will give us the probability that v is less than 4. Probability v equals 0 is e to the negative 11/3, 11/3 to the 0 over 0 factorial. V equals 1, we have e to the negative 11/3, 11/3 to the 1 over 1 factorial, followed by e to the negative 11/3, 11/3 to the 2 over 2 factorial, and e to the negative 11/3, 11/3 to the 3 over 3 factorial. We sum all these and we get a value of 0.501.